European digital infrastructure is migrating away from centralized platform economies. For years, the standard approach was extracting municipal datasets and centralizing them into massive proprietary data lakes. This model surrenders the city's digital sovereignty and hands complete control over to third-party tech operators. The incoming mandate from the European Union replaces this extractive model with federated, sovereign data spaces. But this creates a severe architectural challenge. How do you weave highly fragmented municipal datasets into a single, cohesive public service if you are no longer allowed to centralize the data? The solution is the My3P platform. It operates as an AI-powered cross-domain service layer, connecting local governments to citizens and local businesses. Instead of hoarding information, My3P queries distributed datasets via standardized APIs. The information stays securely at its original source, yet still populates seamlessly on a user screen. Extracting tangible civic value from these environments relies on sophisticated orchestration infrastructure alongside secure data storage. Look at a practical scenario in Hanover, Germany. A visitor opens the My3P application to plan an itinerary centered around an outdoor heritage festival. The initial schedule relies heavily on the local transit network to get across the city. Suddenly, two separate data streams detect a conflict. Severe congestion on the scheduled tram line overlaps with an 80% probability of heavy afternoon rain. The orchestration layer intervenes. A dynamic alert pops up, rerouting the user to a nearby e-bike rental to bypass the transit delay entirely. To avoid the incoming storm, the platform swaps the afternoon festival for a locally owned indoor cultural heritage museum. Directly below this new recommendation is a trust check interface. The app explicitly tells the user exactly why the e-bike and the specific museum were chosen, citing both the detected transit delays and the weather alerts. Delivering that single, seamless reroute requires three distinct architectural layers to execute simultaneously: interoperability, governance, and AI. Pulling back the user interface reveals the orchestration engine processing these variables. The data feeds driving this system possess vastly different structures. The API from the Transit Authority updates by the second, while the museum's ticketing registry is entirely static. Left to their own devices, these disparate data schemas clash. They speak entirely different structural languages. The translation layer relies strictly on the Open and Agile Smart Cities Minimal Interoperability Mechanisms, or MIMs. This universal filter instantly standardizes the feeds. The first crucial component is MIM1, which manages context information using the NGSI-LD standard. MIM1 allows the service to anchor a user's real-time GPS coordinates and build continuous dynamic links to the immediate urban conditions around them. The second component is MIM2, the Shared Data Models Protocol. This resolves semantic conflicts between siloed municipal departments. Standardized models allow the engine to lay a severe weather alert perfectly over a local tram schedule, calculating the overlap. Relying entirely on these shared frameworks eliminates the need for software engineers to write fragile, expensive custom code to bridge every new database. Standardized interoperability is the absolute prerequisite for executing cross-domain smart city orchestration. Local governments will not share that data if they suspect a third-party application will permanently extract and store it. Access requires the Data Space Protocol, an emerging set of technical rules designed to facilitate decentralized sharing. Instead of a central server, My3P relies on certified data space connectors acting as secure bridges linking municipal databases directly to the service layer. To access museum capacity data, these connectors negotiate an automated contract before a single byte moves across the network. These computational contracts are enforced using the Open Digital Rights Language, or ODRL. The original data holder embeds specific ODRL policies directly into their feed, strictly dictating how, when, and by whom their information can be displayed. Certified connectors and ODRL syntax guarantee absolute digital sovereignty, ensuring the host community never loses control of its assets. Directing urban traffic and recommending local businesses using opaque black box artificial intelligence introduces immense civic risk. Opaque recommendation engines frequently prioritize paid placements and global chains, obscuring local enterprise while risking direct violation of the incoming EU AI Act. My3P mitigates this severe risk by embedding explainable artificial intelligence, or XAI, directly into the very foundation of its core digital infrastructure. Deep in the back end, the system utilizes SHAP. Derived from cooperative game theory, SHAP mathematically credits every individual variable that influences a recommendation. In our Hanover scenario, SHAP weighs the exact impact the impending rain and the tram delay had on generating the new itinerary. This provides system administrators with the quantitative proof necessary to ensure the core routing logic is equitable and free from systemic bias. But delivering raw cooperative game theory mathematics to a citizen holding a smartphone in the rain is entirely useless. The architecture resolves this by integrating LIME, local interpretable model-agnostic explanations. LIME acts as an algorithmic translator. It builds a highly simplified surrogate model specifically around the individual prediction made for the user. It filters those complex back-end metrics directly into the front-end trust check interface. By communicating its reasoning clearly, the AI stops operating as a dictatorial black box and functions instead as a trusted civic guide. Algorithmic transparency must exist at both layers: strict mathematical validation for the administrator and immediate clarity for the citizen. Zooming out from the Hanover pilot, this technical stack has deliberate structural implications across the continent. Because the architecture adheres strictly to Data Space's Support Center blueprints and OASC standards, the platform is entirely modular. Deploying a secondary pilot node in structurally distinct municipalities, like Porto, validates how the architectural model adapts across borders. The exact same orchestration logic tested in Germany can process the entirely different data catalogs of Portugal or Belgium without requiring bespoke software development. My3P is the replicable model directly fulfills the strategic mandate of the imminent Digital Europe program call for pilots. The architecture ingests raw, federated data spaces, routes them through interoperability and governance protocols, and synthesizes them into personalized, transparent civic utility. The system guarantees that local SMEs and hidden cultural heritage sites receive unbiased digital visibility. It equips municipalities with the intelligent tools needed to actively mitigate transit congestion and distribute tourist flow evenly across their neighborhoods. This allows cities to generate value from their urban data without ever surrendering control to a proprietary platform. My3P is the architectural bridge required to operationalize the next generation of European digital public infrastructure.